Hello everyone, my name is Abigail Guinan, and today I'll be talking to you about assisted migration of silver maple communities. So let's start to break that term down. What exactly is assisted migration? Assisted migration is based on the idea that plants are a lot like us. They don't like it too hot and they don't like it too cold. There's an ideal temperature range that different plants do best at, and that range is unique for each species. However, we also know that the climate is changing. So the ideal temperature ranges that plants evolve for are starting to move towards the poles and upwards in altitude. So our job is to help make sure that plants can stay in their ideal climate zone to minimize stress. So why should we help plants move? Plants already have mechanisms to reproduce and disperse seeds on their own. Because plants aren't able to move themselves as quickly as the climate is changing. Unlike animals, plants can't get up and walk to a new location when conditions become unfavorable. So assisting plants in their migration is how we ensure that these species and their communities survive. So why not just focus on individual species? Why should we try to focus on the relocation of entire communities? Because plants rarely operate in isolation. Plant communities are able to survive because individual species learn to team up with others in order to handle stress from the environment. For example, through fungal networks, Douglas fir shares carbon with paper birch at different times of year, depending on which species needs the carbon for growth. So, paper birch, as a broad-leaved deciduous tree, gives carbon to Douglas fir in summer when it can get as much sun as it wants, and Douglas fir gives carbon back to paper birch in the spring and fall when its evergreen needles are still around to pick up the sun. In short, one species can't survive as well without the others, so to keep forests functioning, we need to work on protecting the community as a whole, rather than just a few individual species. This project focuses on silver maple communities because silver maple exists across an extremely wide latitudinal range in the United States. This means that silver maple should do fairly well even as the climate gets warmer because it can withstand a wide range of temperatures. However, the species associated with it often have narrower ranges and will need support to move north. Because silver maple acts as a dominant species that defines its community, having silver maple available on a wide latitudinal range provides support for species associated with it. In this way, silver maple is like a ladder that the other species can climb to their ideal climate zones as the climate continues to change. Now that we know why assisted migration matters, we need to know what this project does to help make assisted migration happen. We know that plants will need help migrating, but there's a lot of uncertainty surrounding which specific plants need to be moved and where they need to be moved to. So the purpose of this project is to determine which plants are 1, in need of assisted migration, 2, which ones are likely to survive migration, and 3, where these plants need to be moved to. How do we do this? First, we need to figure out what a silver maple community is. To do this, we compiled forest survey plots and searched for plots containing silver maple and assigned these as silver maple communities. Next, we need to define climate. In this case, we decided to represent climate as hardiness zones, which is the minimum annual temperature that can be expected within a given area. For example, Amherst is in hardiness zone 5B, which means it has a minimum annual temperature of -15 to -10 degrees Fahrenheit. The zone before this is zone 5A, which has a minimum annual temperature of -20 to -15 degrees Fahrenheit. A lower number means a colder temperature, so zone 3A is colder than zone 6A. To make things simpler, we lumped hardiness zones into numerical categories so we could put Amherst in zone 5, which is -20 to -10 degrees Fahrenheit. You might also be wondering why we're using minimum temperature instead of maximum temperature to define climate, especially if climate change mostly involves the climate getting warmer. The reason for that is because minimum temperature tends to have a much greater impact on plant distribution than maximum temperature. It impacts the timing of frost and the length of the growing season, both of which have significant impacts on plant growth. This is why farmers use hardiness zones to figure out when to plant their crops. While warming temperatures can worsen periods of drought and cause increased stress to plant health, this doesn't have the same community impact as changes to the severity and length of minimum temperatures. Next, we needed to make sure that plant communities were actually different across climate zones, and we used multivariate analyses including ANISIM and PERMANOVA to do that. ANISIM is a global test that tells us whether a difference exists between any of our hardiness zones. Terminova tells us which zones are significantly different from each other. From our results, we determined that while there is some overlap between communities, all of the zones are significantly different from each other. To figure out which plants needed to move, we had to determine which plants were driving the differences between communities. And that's because these are the plants that have smaller climate ranges, meaning they'll need to move as climate change progresses. To find those species, we used the indicator species package from the statistical software R. In this package, we used a community structure function called multipat to figure out which species define their communities. This function outputs an indicator value, an A statistic, and a B statistic for each species in the community. We were especially interested in the A statistic, which asks the following. Given the hardiness zone, how likely are we to find the species on a scale of 0 to 1, with 0 being completely unlikely and 1 being certain? We're interested in this value because species that score well on this are strong representatives of their hardiness zone and can continue to be so when these hardiness zones move. From this information, we generated a list of plants that define silver maple communities in different hardiness zones and figured out where these plants need to go. Thankfully, the rule of thumb for this is simple. In the next few decades, hardiness zones are expected to shift by one numeric value. This means that the minimum annual temperature in any given area will be about 10 degrees Fahrenheit warmer. So the plants in Zone 5 would need to go into what is currently Zone 4. And the plants in Zone 6 would replace the ones in Zone 5. Now that we know which plants will be best for which hardiness zones, we need to get this information out to landowners. The way we plan to do this is to communicate with landowning agencies and suggest lists of recommended species to them based on their local hardiness zones. That way, we'll be able to answer the two most crucial questions in climate-suitable planting: which species need to be planted and where they need to be planted. I hope you enjoyed this video presentation. If you have any additional questions, please feel free to visit me at my poster session. Thank you.